Okay, good evening everyone. So it's already 7:05 and we will start the lecture in few minutes. We'll wait for some other students to join. And how was your week? Am I audible? Okay, good. So I think we can start. 9 of us have joined, so let's start. Okay, once again, welcome you all to the live session 5 of this NPTEL course. The course is Physics of Renewable Energy System. This course is taught by Professor Amrish Chandra. He is from Department of Physics, IIT Kharagpur, and the live sessions are conducted by me, Rohit, and I am PMRF scholar at IIT Bombay. Okay, so once again, welcome you all to this live session. Okay, so what I have planned in this week, we will have some revision of previous live session, like what we discussed in the last lecture. Then we will go through some conceptual questions that are taken from previous assignments or lectures. Then we can take your doubts also. So if there is any major doubt, you can save it for the last 10 minutes of the lecture. We will discuss all of them, and in between if there is any doubt, like regarding the lectures or flow of lectures, you get any minor questions, so you can ask in between. Okay, so revision of previous live session. So if you see in previous live session, we have actually discussed about tidal energy, the base load, peak load, the Belamis converter that is used for converting wave energy to this electricity, geothermal power, and also the world's biggest power plant, Three Gorges Dam hydroelectric power plant. Okay, so in tidal energy, what we have seen that this is a very beautiful animation I have taken from the previous lecture. So in tidal energy, what we saw that whenever the tides come, the kinetic energy is actually utilized and stored the water in the reservoir. So this reservoir is full, and when tides goes out, dries away, then this water can easily flow back to the sea. And during its duration of flow back and flow in, this turbine gets rotated. And you know what happens when a turbine rotates? It is coupled with the generator shaft. The generator shaft rotates, and due to Faraday's law of motion, the electromagnetic induction occurs and electricity is generated. Okay, so that's how a tidal energy plant generally works. This concept is basically utilized. There are some other concepts also for tidal energy, but generally it works on this concept only. We utilize the energy of tides, then we convert it to mechanical energy. That mechanical energy rotates the shaft in the generator, and it is converted to electrical energy. So if you see also, there is so much of conversion. Like first, the kinetic energy of tides is converted to mechanical energy, that is rotation of turbine, can also be called rotational energy. Then this rotational energy is converted to electrical energy. Then that electrical energy goes to the grid, then to your house. So you can see that such high uh, times of conversion, stage 1, stage 2, stage 3. What it does, it actually decreases the overall efficiency to very low value. So that's why we don't see tidal energy plants. They are not actually very much feasible. But as the technology is growing, as the new technology, new concepts are being discovered, so in future we will surely have some plants based on the tidal energy. And also there are some pilot scale plants in some countries I think one of the plant is located in Gibraltar Bay or something. You can check it on Google. I would recommend you that you should go and check it on Google also. So there are few pilot scale plants for this tidal energy, but they don't generate much electricity. But the potential for to generate electricity and itself from tidal energy is very huge. It can go up to 120 gigawatt. That is a huge amount of energy. It can power one third of homes or the electricity requirements of India at the current level. Okay, so that's why tidal energy comes from any source is very important. And basically this is a green energy, or you can say renewable energy. So no environmental emission, we are not polluting environment, we are not putting anything extra into the environment, our carbon footprint is also low. So these type of energy always needs to be promoted. Now we discussed in, I think, question 2 or 3, we talked about the base load and peak load. So you students, you know that base load is the minimum load that anyway we have to cater through our power plants. It is the bare minimum load. Like we have lightings, we have fan. That lighting of fan needs to be on or off depending on the requirement. It is the basic load. Then we have washing machine requirements. We watch TV sometimes. We iron our clothes. So these are some basic times, like in the evening, or in winter. You see that we have a heating load requirements. We switch on the electric resistance heaters in the night, or in the summer we see that we in the afternoon we switch on the AC. So what happens, these are the extra loads that add up to the base load, and that is in the form of peak load, which we see here in the curve. So this x-axis actually shows the time, various time of the day, 1 a.m., 5 a.m., 9 a.m., 1 p.m., and the y-axis actually shows the megawatt, that is energy capacity. So that much energy required at this time of the day. And this is a typical summer load profile. So you know what happens in summer. In the summer we see that in afternoon there is so much of solar energy. Solar energy you can't say, there is so much of heat. Okay, somebody wants to join, let me. Huh. In typical summer months, we see that in the afternoon there is a high air conditioning requirement due to the high temperature of the ambient. So that's why this peak load curve is actually showing that in between 1 p.m. to 5 p.m. we have a very high electricity requirement. So that's how these curves are interpreted, the peak load and the base load curve. And these are very important when we go for any power plant designing. We first have to check our peak load curve, the base load curve, and one more important thing, the renewable energy. These energies are basically intermittent in nature, like the professor has also taught in the lecture slides. When we have some intermittent energy, we can't put our peak load on that. So generally renewable energy are actually designed for base load of the plant or base load of the whole society, and the peak load is generally catered by coal power plants, because we can always fire more coal and produce more electricity, but we cannot have increase the efficiency at the go for solar and take more power output. It is actually fixed. Generally it is 20%, so 20% efficiency will always be there. It will convert only 20% of sunlight to the electricity. Okay, but one catch is here. Remember this thing, the hydroelectricity is the only renewable energy, I will say, that can provide both base load and peak load. Why? So you should always ask the question, why hydroelectricity can provide, why solar can provide. Just we know the answer, like solar we can't increase the capacity at the go, but for hydroelectricity we have a big reservoir. Dams have a very big reservoir, like 7 lakh cubic meter cube of water storage. So these water can actually be we can always pass more water through the penstock and produce more electricity at the go. So that's why hydroelectricity plants are actually catered for base load and peak load both. Now the third one is Pelamis converter. This was actually a very important concept for converting wave energy to electricity. Uh, a commercial scale, or you can say in between commercial and pilot scale plant, has been settled in South African or South Korean coast, and it's working very beautifully. It is producing electricity, and basically this Panamis converter are based on hydraulic rams. So what happens, due to the hinge joints, there are some hinge joints there, like here you can see the hinge joints, here you can see the hinge joints. This is the ram, this is the hydraulic fluid, and this is the turbine. Somebody wants to join. That's yes. Okay, in the Pelamis converter, there are some hinge joints in which this you can say devices are connected, and then in between these hinge joints we have ram, turbine, and hydraulic fluid. So what happens when this moves up, this fluid goes here and this comes down. So what happens, this comes down, this fluid will go through this turbine and it will rotate the turbine. When the wave passes, this will go down, there is a crest here, so this will go down, this will push the fluid here, it will go through this will push the piston here and it will pass it through the turbine. So that's how this electricity is produced in the Pelamis converter. The other one for converting wave energy are Edinburgh duct. So you should remember the name. One is Edinburgh duct, second is Pelamis converter. The third thing which we discussed that day was hydroelectricity. It's a very important source of renewable energy, I can say, very important and very powerful. Why I say very powerful? The reason is that we can make very big plants based on this hydroelectricity. We can have 200 megawatts, 300 megawatts of plants also. For Indian scenario, we have Bhakra Nangal Dam, that is the biggest dam in India, and what you should be amazed about its capacity. I've told you in the last lecture also, it can produce 1325 megawatt of electricity. So one thing you have to remember, energy capacity is 1325. That doesn't mean it will always produce 1325. It has the capacity to produce 1325, but it will always produce somewhat lesser than that. So we have a term capacity factor. So that capacity factor will actually tells us about how much electricity it can generate maximum, to how much ratio of actual electricity generation to how much it can produce at maximum. Okay, so there is a term of capacity factor. So these capacity factors are generally very low for renewable energy. That's why there is a very much of concepts revision, research going on to increase these capacity factors. We have storage system also. So this week, if you have gone through the lectures, professor has taught about the storage systems. So that storage systems are nothing. They are integrated with the renewable energy just to increase the capacity factor. Like if we have sunlight in the morning or in the daytime, so what we do, we store it in the battery, we produce electricity, we store it in the battery. In the night time, we can use that inverter and convert the electricity, chemical energy from battery to electricity. So that's how it works. Okay, the fourth thing we discussed that day was geothermal power plant. So geothermal energy is kind of, lots of work is going on. It can be coupled with some other type of energy also. I can't say like it is very much developed or it has a commercial scale application, but we have seen some plants based on geothermal energy. So in that, what happens, we take the hot water, we convert it to steam, because it is taken as hot water. We just need to supply bare minimum energy to convert it to steam. And you know what happens to steam? We just passes through the turbine. It rotates the blade in the turbine. That blade is actually placed on some shaft. That shaft is coupled to generator and it produces electricity. And what happens after turbine? When this steam passes through turbine and rotates the shaft, its energy goes down, it gets liquefied in the form of water. That water is actually cooled in the cooling tower and it is injected back into the well. So again this hot water is taken out and the cycle goes on forever. So that's how geothermal power plants actually works. So this is the revision of previous live session. If you have any queries, you can always write in the chat box. I can read it, or you can ask in the discussion forum. I could see that very less people are using discussion forum. I would suggest that you should use discussion forum to the maximum, because this is the way we can interact. We can know what are your doubts, what are your where you are getting lost in the subject. So we can guide you actually. We can answer your queries. Even if the question you think is not up to the mark, still you can ask it. We will answer. Okay. Now for this session, let me check that anyone to join here. Okay, seems everyone has joined. Nobody is there. Okay, so we will continue with today's lecture. So the first question is, this lecture is basically based on the previous week material, week 5 material, and week 5 material basically consists of energy storage system. So it is a conceptual, more sort of concepts and discussion. So very less numericals are there, but I would suggest you should go through some books. Like one of the book I can recommend for this is Solar Energy by SP Sukhatme. Very good book, and you should go through it. You will get a lot of numericals here. That is not for this NPTEL exam only. You will get to know more things about the this subject. So which of the following is considered as kinetic energy storage system? So options are flywheel, compressed air storage system, pumped hydroelectric, and none of. When you see the kinetic energy, what the first thing comes in your mind? Like kinetic. Kinetic is always associated with speed. So anything which has some speed, rotational speed, linear speed, any type of speed, and it can store energy, is kinetic energy storage system. Okay. We will discuss one by one what is this flywheel, compressed air storage system, pumped hydroelectric, and nanotube. So the correct answer for this is flywheel. Flywheel is basically kinetic energy storage system. Compressed air energy storage systems are generally hydraulic based storage system. They store energy in the form of compressed air. We'll get to know about it in the later slides. Okay, somebody join the lecture. Okay. Okay, so we were discussing about kinetic storage system. So flywheels are basically kinetic wheel storage system. What is flywheel? This is a diagram of flywheel. So I tried to put the images also so that you can visualize it. What is flywheel? I will say that word flywheel. You won't understand. You will feel like it is a simple type of wheel or any type of wheel. So make sure this is not only a wheel. This can store energy. How I will describe in later slides. Second one is compressed air storage system, and third one is pumped hydroelectric. Pumped hydroelectric basically stores energy in the form of potential energy. Okay, so this is not the correct answer. The correct answer is flywheel. Okay, so what do you think? Flywheel is a mechanical or thermal energy storage system? So what do you mean by mechanical? When we talk of word mechanical, it has to have some joints, some rotational motion, some sort of linear motion or anything. Mechanical is a word that is very much related with machines. And what are machines? Machines are basically the relative motion of some links and joints with respect to each other is machine. In simple, very simple terms. Okay. So anything which is related with that motion in mechanical. And when we talk of thermal, thermal is a concept that is very much related with temperature. So if there is any sort of temperature rise or fall is related to thermal. So one more question here. What happens if there is no temperature rise or fall, but can it be thermal? No temperature rise. We just discussed that thermal energy is something that very much associated with temperature rise and fall. But what happens if there is no temperature rise? Still, can it be termed as thermal energy storage? The answer is yes. It can be termed as thermal energy storage. And I have put a numerical also, so you can understand. But I will make it clear here. When we what we do when we actually make water to ice, so water at 0 degree C converts to ice, and at 0 degree C itself, what happens, we take heat away from the water in the fridge or in refrigerator or in some especially content container. We take away the heat. What is that heat? Latent heat of fusion. So how much is that? 335 kilojoule per kg. This is for water and ice. So we take away this heat, and that heat is taken away, so water converts to ice. No temperature rise or gain is here, rise or fall is here, because water was at 0 degree C and the ice is also at 0 degree C. No temperature rise or fall, but still we take away heat and store it somewhere. So this can be termed as a thermal energy storage device. Okay. So make sure if there is a conceptual question asked in the exam, like if there is no rise or fall in energy, can it be termed as thermal energy storage device? So yeah, answer is yes. And we were discussing about flywheel. So flywheel, simple example is you have seen that sugarcane juice machine. So you will see a big wheel in the side of that machine. What does that wheel do? That wheel itself is a flywheel. So what happens actually, when it rotates the sugarcane boy, it rotates the handle of the sugarcane, it only rotates a single time. But during its rotation of single time, that flywheel actually stores that energy. And after he leaves the hand, the flywheel releases that energy, and that both the rollers actually rotates on its behalf due to the energy stored in the flywheel, and we put the sugarcane into it and get the juice out of it. One major example of technical use of this flywheel is in diesel engine. Okay, so I write it down here: diesel engines or IC engines, internal combustion engine. You will see when anybody of you has seen any truck engine. So when you go to any service center, you will see this type. This picture is actually I think from IC engine, truck engine, truck diesel engine. Okay. So when you go to any service center, you will see this type of wheels there. It is fitted on the crankshaft actually through here. And what happens actually, if this is the cylinder, I'm drawing it roughly, okay, for your, and this is the piston. So there are the four stages of IC engine to produce power, okay, and the firing only occurs on firing means we burn the fuel, like combustion of fuel. It only occurs in one stage of these four stages. That's why we call it four-stroke engine. Okay, so only one stage of that four stage has that firing, but still that you don't see car goes forward, stops, then goes forward, then stops. It doesn't happen. So why it doesn't happen? Because of flywheel. So what happens? There is a Gaussian pin here. This crankshaft is here. This rod is here, crankshaft, and a big flywheel is attached in the end. So what happens when this combustion occurs here? It actually moves the crankshaft, and when the crankshaft is moved, this flywheel is also rotated. And during its rotation, it actually stores the energy at high speed. But after the combustion has occurred, the next three stages we don't have any combustion. So because this flywheel has been rotated and it has stored the energy in the form of rotating wheel, it actually releases that energy. It will rotate the shaft itself. And that's how the wheels are actually moved. A continuous movement of the wheel is as well. So that you got to know the how this flywheel actually work. And if you want to see a better visualization, you are always suggested to go to YouTube. See, there are various animations which actually depicts how these flywheels work, and they have very beautifully described it through various motions. How this cylinder movement occurs, how flywheel stores the energy. So you should go and see. Okay. The second one was compressed air storage. So you see, this is a simple cycle pump. When you cycle or a four-wheeler pump, we have a pipe here. We just put it into the tire and fill the air in the tire. This is compressed air storage. So I have put it in very simple terms, just to depict you what is a compressed air storage. So this is a compressed. This also is a compressed air energy storage. Okay, it stores air in the compressed form. That air has a very good amount of energy. If we put it in the tire, instead of putting it in the tire, we put it in on a turbine blade. So what happens? It will push the turbine blade and the turbine will rotate. So that's how this compressed air storage are actually working. They generally work in tandem with gas power plants. Generally they work in tandem with gas power plants. What we do, we take the extra energy, and that extra energy is used to run the compressor. That compressor actually stores the compressed air in very big underground storage. To make it remember, you should know that these storage are very big, not just like a simple 5 liter or 10 liter tank or 20 liter tank. They are very very big, 1 lakh liter or something, 40,000 liters something. So this compressed air is storage here, and that compressed air can be passed through the gas turbine and gas combustor. This is combustor, and it can pass through the gas turbine, and that gas turbine can produce electricity. Now you got to know how this compressor actually storage works. Okay, the next one is pump storage, and pump storage are actually very important, very important. They actually are utilized to store the water that has already flowed through the turbine, and that water is actually what happens. There is a reservoir here. We have a dam here. This whole thing is dam. Okay, this is the penstock. This pipe is called penstock through which water flows. There is a turbine beneath, and that penstock is connected to the turbine. So what happens, from the upper reservoir that is located at a very high head, we take the water and pass it through the turbine. And after passing it through the turbine, we don't let the water go into the river. We just store the water in a lower reservoir. Okay, maybe some water can go to the river because we have to maintain the continuity of river also. So maximum of the water is stored in the lower reservoir, some water is flown to the river. And in the night, when we go to sleep, there is a very less power requirement. Okay. So when there is a very less power requirement, there is extra power that is produced by the turbine. That extra power can be utilized to run the turbine in reverse motion. So what happens when we run the turbine on reverse motion? It will take the water from here and pump it to the reservoir back. So what is it is doing? It is giving energy to the water and storing it in the form of potential energy. So again that water can be utilized. So that's how this pumped hydroelectric system actually works. And actually most of the scientists are recommending that whatever hydroelectric power plants we have or we are building in future, it should have pumped hydroelectric in its functionality. It is a must requirement. So you see that there is a upper reservoir, a very big reservoir, and there is a lower reservoir. So we have a two reservoir system in pumped hydroelectric. So if you go to any dam or hydroelectric plant, if you see a two reservoir, one is upper reservoir, one is lower reservoir after the dam, then we shows that hydroelectric dam is pumped hydro system. Now we come to the question 2. Which of the following two energy systems have the highest energy density? So let me see if anyone wants to join. Okay, no one is there to join. So which of the two energy systems have the highest energy density? So the first thing which we will talk about here, what is energy density? Because if you don't know the term energy density, we can't decide which system has the highest energy density. So energy density is basically amount of energy that is stored in a given system per unit volume or per unit mass also. Per unit volume or mass. So you know volume is in meter cube and mass is in kg. So this is a very important concept. Why coal power plants actually work on coal? Why we have coal power plants? Why we don't have um, wood power plants? We can also burn wood to produce electricity, but we burn coal only. The question here is why? Why coal only? That's because 1 kg of coal can store more energy than 1 kg of wood. So how much 1 kg of coal can store energy? It has energy value of 28 to 32. Depends on the grade of coal. Okay, if it's cheap, then it will have energy value something 10 or 12 megajoule. And what happens if we burn 1 kg of wood? So there are different varieties of wood. If we talk about firewood, then it has an energy capacity of 18 to 20 megajoule. Okay, so that's 75% or 60% of the energy of the coal. So that's why we prefer coal over this wood. Why we prefer nuclear power plants over coal power plants? It's not about the renewable energy only. Probably 1 kg of nuclear fuel, or you can say 1 kg of uranium can power Earth for 2-3 years. That's the energy density of nuclear fuel. Okay, so you should actually very much go through these energy density values of different energy systems. So I have listed a graph also here. This graph is taken from Getty et al. And that's a very good paper. We actually listed the energy density versus power density curve and put the various systems and ranked them. If we see the supercapacitors, we'll also discuss what are supercapacitors. But for uh, this slide, you just take it here. The supercapacitors are actually here. The NICD batteries are here. Lead acid batteries, we don't have any lead acid battery, but they are lower than supercapacitors. They actually sit here. Lead acid battery. What a lead acid battery? The normal battery we use in home. At PVP we go to cathode anode batteries. Okay. Fuel cell. So we see fuel cell here. Okay. So we see that which of the two has highest energy density, that is fuel cell has highest. We see here as it goes above, we get a high energy density value. So fuel cell has high energy density value and nickel cadmium has high energy density value other than the rest of these two options. So the correct answer is B and D. Okay. And in the next slide we will actually discuss supercapacitor, nickel cadmium battery, lead acid battery and fuel cell also. So what are supercapacitor? How they are different from capacitor, normal capacitors? Normal capacitors, I can give you an example that we use it in fan. The fan condenser is actually normal capacitor, okay, and it actually stores energy. We require a very high torque just to move the fan, but that high torque cannot be provided by the electricity. So we just need a very high charge just to provide a very high current there, so that it can provide an initial torque. After that initial torque, it can rotate the fan. A fan can go on full sound. So that high electric charge can be stored in supercapacitors for a moment of 0.1 seconds or something very less than that. That can be given, and initial motion can be given, or the inertia can be break, and that fan will work on its own by electricity. Okay, but how that does that differ from supercapacitors? So when we see a capacitor, it has two layers. There is a dielectric in between them. So focus on this word dielectric. We use dielectric in supercapacitors. Okay. So there is some charge dissociation here. The charge is stored in the layers. Here negative charge, here positive charge are separated. So that's how supercapacitor actually works. Epsilon naught A upon D is capacitance. Okay. But in capacitor, but in supercapacitor we don't use dielectric. We use two collectors, two cathodes and anodes. You can say there is a electrolyte in between these two layers, and that electrolyte, but we have in capacitor we have dielectric, but here we have electrolyte. Why electrolyte? Because electrolytes are more conductive and it can actually facilitate more ion production. And there is a semi-permeable membrane here. You can see in the picture also, this is the semi-permeable membrane. And when charge is actually produced, so there is a double layer of charge stored here. You can see there is a positive charge lining here, there is a negative charge lining here. Here positive and here negative. So there is a double layer also. So that's how this difference is actually in between the capacitor and capacitor. Due to this double layer, more charge can be stored in supercapacitor, and they actually behave like batteries. For a moment of 0.1 second or something, they behave like batteries. So supercapacitors are in between capacitors and batteries, and more research is going on to make it last longer, behave it more like battery. Maybe in after upcoming 3-4 years, we will see that instead of batteries, we are using supercapacitor just to store the charge or energy. Okay. In lead acid battery, we have cathode and anode. The cathode is basically lead, and the anode is lead oxide. So there is a redox reduction oxidation reaction take place in the presence of electrolyte, and that's how the charge transfer occurs. And this is the whole lead acid battery. Nickel cadmium battery, this cathode and anode are actually, for lead acid battery, are actually replaced with nickel and cadmium electrodes. Okay, and in between the electrolyte is also in the form of solid, not liquid form. Okay, but the functionality is almost same, the redox reaction, and that's how nickel cadmium battery actually works. Nickel cadmium battery can be very small also and can store more charge. Now the question 3, amount of energy that can be extracted in comparison to the input energy is known as. So this is basically a very conceptual question. We don't have to put more effort into it. And what is it is saying? The amount of energy that can be extracted. So you have energy stored in something, some thermal energy storage system or any other energy storage system, and we have to extract some energy out of it. So option A is whole, it can be called whole energy. So we don't have any term whole energy. Whole energy is basically the energy that is stored. Another one is approximate energy, round trip energy, total efficiency. So it is actually a round trip energy. What is round trip energy? We will actually not call it round trip energy, it is basically a round trip efficiency. So round trip efficiency is percentage of electricity that is put into storage that is later retrieved. So we store some electricity in a system in battery, like we store 500 megawatt in a battery. That's very huge number. We store 5 kilowatt in battery, okay, and but we can only take 3 kilowatts from that battery. What is round trip efficiency here? 3 kilowatt upon 5 kilowatt, that is 0.6. So this is simple conceptual question, so you just have to remember the concept here, round trip efficiency. So the correct answer is B. Now the question 4. Let me see if there anyone who wants to join. If there are any questions from your side? No questions. Are you guys listening? Okay. Uh, I would encourage you all guys to actually ask questions so that I can also know that I am teaching good, or you guys have any doubts in that specific subject, so I can put more effort into that. Okay, so always encourage to ask questions. I would love to answer your queries. We can find answers to difficult questions also, and we can go to some other level also, other level of discussion, like if anyone has some contemporary advancement he knows about that, can also put it here. Okay, sir, this is the work that is going on in this field, so we'll discuss that also. Okay, so in question 4, this is a simple question which we discussed earlier also. How many reservoirs are there in the PHS energy storage system? So PHS is basically pumped hydro energy. Why it is energy storage system? Because we store energy in the form of reservoir. So we discussed in the previous slide also, like how much should be the reservoir number. One reservoir is main reservoir through which the water flows to the turbine and we take it out in the form of electricity. Then that water which passes through the turbine gets stored in the lower reservoir. After that lower reservoir, we pump that water by reversing that turbine, or we can put a separate pump also, but generally the turbine is reversed. Okay, we can pump it back to the main reservoir, and the next day we can again put this through the turbine thing and we generate electricity. So what we are doing, we are passing it here, we are again storing it here. So pumped hydro storage, no loss of water is there, so that's why it is a renewable energy. We can utilize it again and again for infinity. The only loss which will be here is that any spillage or evaporation loss or any other loss that can occur in between flow of this two reservoir. Okay, so how many reservoir do we need? One and one. So the correct answer is 2. Now again a conceptual question. Maximum efficiency obtained from flywheel based energy storage system is. So the maximum efficiency, you should know about different storage system and how much it can give the maximum efficiency. And I can say that flywheel based energy storage system being a mechanical system, you always see that mechanical systems have very low efficiency generally. But this flywheel storage system has 90% efficiency. That's why it is utilized in the IC engine. So you can see flywheel in the sugarcane machine, also sugarcane juice making machine. You can see flywheel in the, when you go to villages you see a very big round wheel that can be utilized to, what I can say, for crop cutting and fodder thing, fodder for animals like cows, buffaloes. So that fodder is prepared through that big wheel, and we have a cutting blade attached to that wheel, and that wheel rotates. We rotate the handle like this. This is like this, a very big wheel. So I think most of you have seen it like this, and we have a very big handle here, and there we have a tray and a stand. So this big wheel is rotated, and with this rotator we rotate it one time, but still it stores the energy and it can go through cutting that. This is cutting blade. Okay, so we put the fodder here, it cuts into small pieces. That small pieces is actually fodder for animals. So that's you can see this machine in what do you say, in the village basically, or a more mechanized or advanced version is thresher. So okay, so this is how, this is a flywheel. This thing is flywheel. So I just want to make you visualize how these flywheels work. So this can be a very good example. Now the next question, and I think this is the last question. So after this there is a conceptual question, and we will take your doubts, any other things which you want to discuss. So what is the strategy to run the compressed air storage system continuously? So what is compressed air storage system? We saw that in slide 2 or 3, that we store that in a tank. We have a tank, we put, there is a compressor, and air is input from here. That air is compressed and stored in the tank, and basically that air can be utilized for running gas turbines. Okay, so what happens actually, there can be 2 or 3 methods: diabatically, adiabatically, and isothermally. We can compress the air through these methods. In diabatically we don't have any consideration, we just put the air in the compressor and that compressor compresses the air. But in adiabatically we have to conserve the heat, and that heat is actually taken by the system is here, present here. That heat is taken by the system, that system stores the energy, and when we have to utilize that air, we just pass it through that system, and that it gains the heat again. Okay, so there is no loss of heat, that's why it is called adiabatic system. And because when we compress any air or compress something, you can see that there is a rise in temperature. That rise in temperature actually can be utilized to eliminate the combustion chamber in the gas turbine. So you know how gas turbine works. There is a compressor, there is a combustion chamber where the air is heated, then it is passed through a turbine. That turbine is actually coupled with that compressor, and electricity output is taken out. Okay, but here we take the heat from the storage system, and that heat is coming from air. Due to the compression of air, it is actually heated. That heat is taken out and stored in the system. Okay, and that heat is again taken out when required. So this can be eliminated. Only this and this is required. So this actually is the major component of gas turbine. It actually takes very much energy just to heat the air, and that can be, this stage can be bypassed. This can be taken from this here, and it passes through the turbine, and it rotates the blade, electricity is generated. Simple thing. So how can we run the compressed air storage system continuously? Because heat is produced, and that heat is to be taken out. If we don't take the heat out, what happens? It will increase and increase and increase buildup of heat, and due to this heat buildup, it actually happens that the efficiency can go down, the product can melt, there can be damage to the system also, or even it can happen that the storage can be damaged. So for a long-term strategy for working continuously, we have to take this heat out. And how we take this heat out? We utilize heat exchangers. Okay, so the correct answer is C. We don't need to lower the efficiency. Why should we lower the efficiency? The efficiency is always even if 2% increase in efficiency, it is a very big increase. Using the low density air. Low density air, if we use, what happens? It will compress to a very high value. So using a low density air is not going to help. Using a big reservoir, that can be a good option, but anything big comes with expenditure of energy. So big reservoir, more air to be compressed there, more quantity of air required, so more compressor has to run, so it will take down the efficiency, lower the efficiency. Okay, so that's why using a big reservoir is also not a big strategy. You have to use a heat exchanger. And the last question, calculate the latent heat and sensible heat. This question I put just to make you understand the thermal storage system. So you know latent load is load that heat that is taken in and out from the system, in or out, not in and out, in or out from the system without any change in temperature. But we don't have any change in temperature, and that heat that goes into the system or taken out is latent heat. But if there is a rise in temperature, even if it's 0.1 degree Celsius rise, then we will say that there is a sensible load. Okay, sensible heating or cooling has taken place. So there is a 4 kg of water. So what is the mass? Mass is 4 kg. Okay, so we know the mass, and thermal fluid undergoes from 10 degrees Celsius. So there is 10 degrees Celsius. 10 degrees Celsius, what we have? Water. So water actually goes to 0 degrees Celsius. At 0 degrees Celsius, what we have? Ice. Okay, and then it goes to -5. So because there is a lowering of temperature, so we will have sensible heat here, 10 to 0. There is also a lowering of temperature here, 0 to -5. So we have a sensible heat here also. And at 0 degrees C, we see that there is a phase change. So latent heat or cooling is always associated with some phase change. So there is phase change. Phase change is what? The water is converting to ice. So there is a phase change. So there must be a latent heat or cooling also. Okay. So we just have to determine how much is this. If we take this to from 10 degrees Celsius to -5. So we know sensible heat. I just put the formula. We just have to put the values. Mass is 4 kg. Specific heat of water, how much is it? 4.18. And we went from 10 to 0. 10 minus 0. Okay. So another one, sensible heat. This is the sensible heat one that goes from 10 to 0. The another one is 0 to -5. So we can take generally sensible or specific heat of ice varies, and it is actually different from water, but for this question we take it as 4.18 only. So 4K, there is also you have to know how much is the sensible heat of ice. So this can be assignment for you also. I will ask in the next class how much is the specific heat of ice. So we take it for here 4.18, and it actually goes from 0 minus -5. It goes from 0 to -5 to 0 minus -5. Okay, so this is the total sensible load. And for latent load, what we do, we know the mass 4 kg here at 0 degree C, and we know the latent heat of fusion of ice 335. Okay, what you have to do, you just have to calculate this value and add. So if you calculate this value and add, the correct answer is 1590.8 kilojoule. And make sure you utilize the units. You check the units when you do these calculations, because if everything is in kilojoule, so you have to take a specific heat in kilojoule per kg. But if kilojoule per kg Kelvin, okay, specific heat unit is this kilojoule per kg Kelvin. But if everything is joule, required in joule, so you take it as joule per kg Kelvin. So in joule, what will happen? We multiply it by 1000. 4.18 in kilojoule per kg Kelvin and 4180 in joule per kg Kelvin. Okay, so that's how this numerical is solved. It's a very simple numerical, very simple, just to understand the thermal concept, the concept of thermal energy storage. So we discussed a lot of things. We went from revision, then to kinetic energy storage system, flywheel, compressed air storage, pumped hydro, high energy density, what is energy density, then supercapacitors, lead acid battery, nickel cadmium battery, then input energy, round trip energy, round trip efficiency, how many reservoirs in pumped hydro storage, maximum efficiency of flywheel, that is 90%. How we can maximize the compressed air storage system to run it continuously using heat exchangers, and then we also calculated a numerical. Okay, so that's how this live session is complete from my side, and I'm sure you should have some queries. If there are any queries, any small queries, don't think of any urge. If you have any urge to ask, you can ask. Okay, no need to feel ashamed. Even if your question is very small, it can benefit a lot of people, because I put these slides. Also I put these videos in YouTube channel also, so you can go through that channel. The links are in the, when you open the NPTEL, there is a problem solving session, so you can, me and Ravi both put these videos in YouTube channel. If anyone wants to go them again and again after this lecture, so you are always welcome, go through it. Have queries, you can always find me at my email, or else you can write it in the discussion box. I will always welcome to have it in the discussion forum, so that lots of people can benefit from the answers and your questions. So that's how today's lecture is end. And if you have any queries, you are feel free to ask. Please feel free. Yeah, who is this? Okay, for today's session, there is no doubt. Okay, so if there are no doubts for today's session, you all can leave the meeting. So session is over from my side. So we will meet again at the next week, same time. And for that day, best wishes to you all. Have a very good week ahead. And if there are any queries, you can always, you are always welcome to ask them in the discussion forum. Okay. So thank you all. Thank you everyone. You all can leave the meeting. Welcome.